For this problem, we want the platform to support 2 workers and their toolboxes, and with a displacement of less than 5 millimeters in any location and a safety factor greater than 4. This work platform is used in aviation mechanics, where the mechanics would roll this up to the airplane and then put a chain across here as a safety measure, and then the plane is on this side so they can work on this platform. And then we want to see whether this platform is strong enough, and also perhaps we could change the material, make it lighter weight. So these frame elements are made with steel. Perhaps we could make those out of aluminum so that it would be lighter, easier to push around. The first thing I'm going to do is define the up direction, top direction for this. So I'll go on the view cube so that we're looking at it from the top, and I'll say set this current view as the top view. And so now we see this is the front and this is the top. Then if I come over here and I look under representations and I go to level of detail, so right now I'm on the master level of detail where we see all of the components. And then if I go down here to main structure and I double click on that, it took away the steps here, and if I double click on steps we see only the steps. So I'm going to go back to main structure, and we see both some content center parts or some model parts. So we have these wheels here, we have these fittings here, and we have this platform and this plate and connector back here. Anything that isn't created using the frame generator will be ignored when doing frame analysis. So if I go into environments and I go to frame analysis and to create a simulation, and I can tell it what model state I want with the level of detail, whether I want master or main structure, so forth. And I've got it on main structure. Notice these components all gray out because they weren't created with the frame generator. Now I think it'll be easier if we just hide this plate to make it easier to see what we're doing. So I'm going to go back to frame analysis, back to the assembly environment, and on this main structure with it active, I'm going to right click on this platform and I'll turn off the visibility of the platform. Let me save it in that condition. Alright, so I have 5 beams here, this one going across here, this one, this one, this one, and this one. So those 5 beams will support the weight of that platform that we just turned the visibility off, plus 2 workers, plus their toolboxes. And so let's make that a total of 250 kilograms. And so we need to spread that 250 kilograms across these 5 frame members. So I need to know how long those are. When we put in that weight, we need to multiply it times gravity. So I'm going to go back to frame analysis, and so when we put in the load, we're going to put it in as newtons, and so we'll have to multiply this by gravity, and we're going to round gravity. Instead of 9.8, we're going to call it 10 meters per second squared to make the math real easy. And so I need to know what the length of this piece is, and then I have three components of that, and then I have 2 components of this. So if I come over here to the beams and I select this beam, I see that that's beam number 8, and you could also turn on these beam labels to see what beam that was. And I'll right click on beam 8 and I'll go to beam properties, and so it's a 48.3 diameter pipe with a 1.6 millimeter wall thickness, and the length of it is 1010 millimeters, or just over 1 meter. And there are 3 of those, so there's 1, 2, so 3 times that length. Then there is this part and this part, so I need to find that part, and so that I'll go to the properties of that one, and so this one is 1680 millimeters long. So I have two of those. I need to make sure I get the right one here. Actually, these would all be the same, but this one and this one, that's the ones that we're looking at. Alright, so I need to do the math to place that load. I have 6390 millimeters, or total length of all of those beam elements, divided by the 2,500 newtons, and so I need to put in 2.556 newtons per millimeter. So the first thing I'll do is define the direction for gravity. So let's go to our loads, and I'll right click on gravity and I'll select edit, and I see that gravity is going in the y direction. I want to go in the negative x, or in the, actually this is in the positive x direction. So I'm going to tell it to go in the x direction, and I need to flip that direction, so I'll flip it so gravity is now going down. I want to put a pin constraint on the end of this, and so if I do pinned, and I try to select that blue dot in here, I may have trouble getting it because it's behind all of this, but if I can get it, I'll click on it, and I tried to get it and I didn't get it, so I will do that pinned again, and I'll select out here, but it puts it up here. I want it put down there. It's putting in an offset distance, but I really don't know how long this part is, so I'm going to cancel out of this, and I'm going to go to the frame analysis settings, and here where it says use heads-up display, I'm going to turn that off. Actually, while we're here, let's look at some other settings in here. So if I go to the beam model, I can set it to be invisible. The components themselves are invisible, or I could set them to be transparent so we could see through those, or I could do those components as shaded. Normally when we're setting up our analysis, we want the parts themselves, the components, to be invisible, so we just see the nodes and the beam elements. There's a setting here for creating rigid links, so that there's a link between here and here and here, and we may end up having an opening someplace. The problem is if we put that number too large, we could jump across a place where we shouldn't have a connection. But if we put it too small, we may not get a connection that we should have. So we kind of got to look around and make sure that we have all the connections that we should have, but no connections that we shouldn't have, the rigid links. And it looks like it's okay with the setting where we were at, so there's no missing. So this node has to be connected over here to this node. Now notice on this one, so this node was out to this beam element, and so we didn't need a rigid link to be placed by Inventor in that location. We can also set the colors of our various items and the scale or the size of the glyph, and we may come back in here and change some of this stuff later. But let's go ahead and now, so what we did, the step that we did is we turned off this heads-up display. So if I go up here under display and I tell it to show boundary conditions, go back through these settings again. So I turn off heads-up display, and I'm going to change the color of this constraint. So if I click on this, I can pick some other color for the constraint, and I'll say apply to that, and then I'll do my pin constraint again. I will select this beam element. I'll put it on relative. I want this one at 100% or 1. And again, so I forgot to turn that back on, the visibility. So I just placed it in there. We see that the constraint is over here, so I need to go to display and turn on that boundary condition. So we see that pin constraint is right there. And then I'll put in the other three. So I'll do another pin constraint. I'll select this beam element. I'll do relative, and I want this, so notice this number is small, so 0 will be here, 1 would be up here, so I'm going to put that at 0, and I'll apply that, and then I'll select this one, and I'll do relative, and I want that one to be at 1, apply that, and then I'll select this beam relative, and I want that to be 1. Alright, so I've applied the pin constraints in these 4 corners where the wheels are, and then I want to put my load on here. And so I'll go up to do a continuous load, and I'm going to select for the beam. I'll select this beam. We already calculated that the length of that beam was 1680, or we found that in the properties, and we want to do that as 2.556 newtons per millimeter. And I'm going to copy this and put that on the clipboard, so I'll Control C to copy that. I'll do apply, and then I'm going to select this one, and it's still in there, so I can do apply, and that one, the length of that was 1010, and I'll select this one. Now notice we could drag these handles to put an angle this way, or we can drag it this way if we wanted to put those loads in at an angle or a compound angle. And I'll select this one, and I'll apply that one, and I'll select this one, and I'll say OK to that. Now I may want to change the color of these continuous loads. If I go to frame analysis settings and I go to loads, if I want to change those loads to some other color, I could pick a different color, and I could also change the scale of those if I want those to be bigger or smaller. And so I'm going to do that 0.5, make that the glyph for those loads smaller and a different color. Now if we go to the beams and we go to the beam properties, again we can get the section geometry. Remember doing that from DSG 323, calculating the section modules and so forth. And then we can also get the material properties. So if I go and right click and I go to beam materials, and I get the density of the material, the Young's modulus, and the yield strength for that particular part's material. So we've assigned our constraints, we've just assigned our loads, we have our links were created, or rigid links were created automatically for us in this case. In a future lab we'll see how we can add rigid links that aren't added automatically. We're ready to run our simulation. Now when I ran the simulation, I got results that I didn't expect. The displacement is greater than what I was expecting, and if I go to the S max, the normal stress S max, my stress is much higher than what I was expecting. And I realized I made a mistake in my mathematics when I calculated the load that we should put on the frame. Gravity is given in meters per second, and my length was in millimeters, so I need to divide that by 1,000. And so if I do the 2500 divided by 6.39, then I get 391 newtons per meter, but I need to move that decimal place over 3 decimal places, so my load should be 0.391 newtons per millimeter. So we'll need to go back and change this. So I'll go to my continuous load, and I'll do that as 0.391, and let me put this on the clipboard, and I'll get the second one, and I'll get the third one, and the fourth one, and the fifth one. Most common mistake is calculations with the wrong units. We'll run the simulation again. So we see our displacement and then our stress, and we'll have to hand calculate the safety factor. When we're doing a frame analysis, it doesn't show the safety factor. Keep in mind that the positive numbers are in tension and the negative numbers are in compression. So when it gets down into this cyan or dark blue areas, those areas are in compression. Our high tension is back in this area, and somewhat in this area. In the next step, let's add the stairs to the structure and see how that affects the displacement. So I'm going to go to the step platform and I will unsuppress the step platform. And again, the treads are not included in the analysis, so I'll shift right mouse button and set my selection filter to part priority, and then I'll right click and turn off the visibility of these treads. So any parts that aren't created with the frame generator will be ignored. There's some additional parts in here that are still visible, and I think we can turn off the visibility of these parts as well. We don't really have to turn those off. There's a bunch of fasteners in here too. I'll just leave those visible, but these pieces that go on the front of the tread, these rubber pieces, we can turn those off. And I'll save the file and then go back to the frame analysis. So I'll go to frame analysis, and when we see a lightning bolt over here, that's letting us know that we need to update our frame. And so I'll go ahead and click on update. And we're given an error about some material properties that are missing. I don't think these actually affect our analysis, but we'll see if we can fix these. So if we expand this a little bit, we can see which beam are missing some information for torsional section modulus. Now let's go up here to the beams and right click on beams and go to beam properties. And so we'll go to this 25 by 25 by 3, and so the torsional section modulus is missing right here. Let's put in for that number 2270 cubic millimeters, 2270. And actually it's not letting me enter that number, so we're going to have to override this. So I'm going to select that, and I'll do customize, and now that's white or available. It's no longer grayed out, and so I'll put in the 2270, and I'll hit the tab key and I'll apply that, and then I'm going to select the 60 by 30 and I'll hold down the shift key and get all three of those, and I'll do customize, and I'm going to put in for the section modulus for those as 6137. And then notice that there's nothing listed under the I or issues anymore, and so we can run the simulation. So we see that our displacement has decreased by about 50%, so adding the stairs did stiffen up the assembly. And if we go to the results and we'll go to the normal stresses and S max, we see our S max has been reduced. So in the next step, we want to replace the steel frame members with aluminum frame members. Now we don't want to go through all the work of doing that and then find out that we can't use aluminum. So there's a simplified way of doing this, that we can put in the section properties for the aluminum, run the analysis without going through and changing all of these frame members. So the first thing I need to do before I change it, so these the beam materials were mild steel. Let's copy this simulation. So I'll do copy simulation, and then on simulation 2, let's change those beam materials. So I'll right click, I'll go to beam materials, I'll select customize, I'll select all of them with the shift key, and I'll change all of those to aluminum 6061, and then just click on some of them, make sure that it has in fact that stays on aluminum 6061. Alright, we'll run the simulation again. We'll record our results. So now we have a displacement of about 2 millimeters. That's less than our 5 millimeter max. And if we look at our results under normal stresses and S max, we can calculate the safety factor. We'll then copy simulation 2. So I'll select simulation 2 and do copy study again. And so now I have active simulation number 3, and I want to change the beam properties for only these beams back here. So we're not going to do for everything, but for a good portion of it. So I'm going to right click on beams, and I'm going to go to beam properties, and I'm only going to change the beam properties for this ISO 4200 48.3 diameter by 1.6 wall thickness. And so I'm going to select the first one. Actually, let's go ahead and do customize. Then I'll select the first one. I'll hold down the shift key. I'll select the last one. And then I'm going to change the section width. And because this is a round pipe, the height will be equal to the width. And so let's make this smaller. We'll change that to 33.7 for the width and the height. We'll change the area to 306.6. So we're going to make the wall thickness thicker. We made the pipe diameter smaller, but the wall thickness we made thicker. And so for the centroid, we're going to change that to 16.85. And it's a round pipe, so both X and Y. We will change this value to 35,982. And it's, the moment of inertia in Y also 35,982. And then we'll change Z, the section modulus, to 2139. Alright, so we've changed the properties of our beams without changing the physical size of the beams themselves. If this all works out, then we can go back to the assembly and change the actual size of the beams. So we'll say OK to that. And so we've overridden the beam properties. I'll run the simulation again. We check our maximum displacement, and it's less than the 5 millimeters that we set as our what we could allow. And if I check the S max, we see the X max is 36.82. We can calculate the safety factor.